Have you ever wondered how type conversion works in Java? Well, it's a fascinating and crucial part of programming that allows us to transform data from one type to another. Type conversion, also known as typecasting, is a mechanism that enables the programmer to convert data from one data type to another, ensuring compatibility and smooth execution of the code. Now, there are two main types of type conversion. First up, we have implicit type conversion, also known as automatic type conversion. This is where Java does all the heavy lifting for you, taking care of the conversion process behind the scenes. The second type is explicit type conversion, where the programmer manually converts data from one type to another. This is typically necessary when the data types involved are not compatible with each other. This concept may seem a bit abstract now, but don't worry. Stay with us as we delve into the world of type conversion in Java. Let's start with implicit type conversion, also known as automatic type conversion. This is an interesting feature of Java where the data type of a variable is automatically changed. It's like Java's own magic trick. But don't worry, it's not as mysterious as it sounds. It's actually a pretty straightforward process. In implicit conversion, Java takes the reins and converts smaller data types to larger ones automatically. This is done to avoid potential data loss. Imagine you're pouring a small cup of water into a large jug. The water from the cup fits into the jug without any issues, right? Similarly, when we try to fit a smaller data type into a larger one, Java does it with ease. For instance, when you assign an integer value to a double variable, Java automatically converts the integer to double. Let's consider a simple piece of code. Double my double equals sign 10. Here, the integer 10 is automatically converted to double, and its value becomes 10.0. But what happens when we try to fit a larger data type into a smaller one? Well, Java doesn't perform implicit conversion in this case, as it could lead to data loss or overflow. It's like trying to pour a jug of water into a small cup. That's not going to end well, is it? That's why Java uses implicit conversion only when it's safe to do so. It's a way for Java to ensure that your data is handled properly, without any unwanted surprises. However, it's important to note that implicit conversion can only occur between compatible data types, such as numeric types. You can't implicitly convert a Boolean to an integer or a string to a float. It's like trying to mix oil and water, they just don't go together. So that's how implicit conversion works, but what about when we need more control? When Java's automatic conversion isn't enough, we turn to explicit type conversion. So, what is explicit type conversion? It's a method used in Java to convert data from one type to another, manually. Unlike implicit conversion, which is performed automatically by Java, explicit conversion is something we, as programmers, have to do ourselves. Now you might be wondering, why is explicit conversion necessary? Well, there are times when we need to store data in a certain type, but the data we're working with is of a different type. In these situations, Java's automatic conversion won't suffice, which is where explicit conversion comes in handy. Let's take an example to understand this. Suppose we have a floating point number, say 3.14, and we want to convert it into an integer. Java's automatic conversion won't be able to do this, because it only converts smaller types to larger ones, not the other way around. So we'll have to manually convert the float to an integer, using explicit conversion. However, one important thing to note here is the risk of data loss. When we convert a larger type to a smaller one, like in our example, we might lose some information. In this case, the decimal part of the float would be lost, and we'd be left with just 3. This is something we need to be mindful of when using explicit conversion, but don't let this scare you away. Yes, explicit conversion does come with a risk, but it also provides us with more control over our code. We can ensure our data is in the exact format we need it to be in, and we can also handle any potential issues that might arise due to the conversion, such as data loss. In a nutshell, explicit conversion is a powerful tool in Java, allowing us to manually convert data types when automatic conversion falls short. It's a bit like driving a manual car. It gives you more control, but you also have to be more attentive. Explicit conversion gives us more control, but it's also a responsibility. Now, let's talk about how we can perform explicit type conversion through casting. Casting in Java is a fascinating concept. It allows us to convert one data type into another. Imagine having a double value, and you need to convert it into an integer. Or perhaps you have a float that you want to change into a string. That's when casting comes into play. Let's dive into the mechanics of casting. In Java, we have two types of casting: widening casting and narrowing casting. Widening casting, also known as automatic conversion, happens when we convert a smaller data type to a larger one. This process happens automatically because there's no risk of data loss. For instance, converting an integer to a double. On the other hand, narrowing casting is when we convert a larger data type to a smaller one. This process requires explicit casting because there's a risk of data loss. For example, converting a double to an integer. Now let's see how to cast variables in Java. To perform a cast, you write the target type in parentheses before the variable or value you want to convert. Let's say we have a double value of 9.7, and we want to convert it into an integer. We would write it as follows: int myInt =, int myDouble. Here's another example. If we want to convert an integer to a string, we could use the toString method of the integer class, like this: string mystring =, integer.toStringMyInt. Remember, casting can be incredibly useful, but it's not without its risks. When you're narrowing a cast, you may lose some data. For example, if you cast a double to an integer, the fraction part will be lost. So, always be mindful of what you're casting and why. In summary, casting is a powerful tool in Java that allows us to convert data types. It provides us with the flexibility to use data in the ways that best suit our programming needs. Casting allows us to handle conversions manually, ensuring we get the results we want. Understanding the rules of type conversion can save us from many programming headaches. So let's dive right into the intricacies of type conversion rules in Java. Firstly, we must recognize that Java is a statically typed language, which means the type of every variable must be known at compile time. Therefore, type conversion is a critical aspect of Java programming. We have two primary forms of type conversion: implicit and explicit. In implicit conversion, also known as automatic conversion, the Java compiler automatically converts a smaller type to a larger type. It's like fitting a small box into a larger one, no problem there. Explicit conversion, on the other hand, involves converting a larger type to a smaller one. This is like trying to fit a large box into a smaller one. It requires some effort. This is where casting comes into play, where we tell the compiler to convert the type, even if it means losing some data. Now, what are the rules that govern these conversions? First and foremost is the hierarchy of data types. At the bottom of the hierarchy, we have byte, then short, followed by int, long, float, and finally double at the top. Implicit conversion can happen upwards in this hierarchy, but for moving downwards, explicit conversion is required. Another rule to remember is that characters can be implicitly converted to an integer type, since char in Java is essentially a subset of int. However, to convert an integer type to char, explicit casting is required. Also, Boolean type in Java stands alone. It cannot be converted to any other type, nor can any other type be converted to Boolean. Finally, objects of a subclass can be implicitly converted to a superclass type. But to convert a superclass object to a subclass, explicit casting is required. Knowing these rules will help you navigate type conversion in Java with ease. So keep practicing and happy coding. We've covered a lot today, so let's take a moment to summarize. Type conversion at its core is a fundamental concept in Java programming, allowing programmers to convert data from one type to another. We've explored both implicit and explicit type conversion. Implicit conversion happens automatically, where smaller data types are converted to larger ones without any data loss. On the other hand, explicit conversion, also known as casting, requires a little more attention as it involves converting larger data types to smaller ones, potentially leading to data loss if not handled correctly. We also delved into the intricacies of casting in Java, a technique used to convert variables from one data type to another. And finally, we discussed the rules of type conversion, providing a roadmap to navigate the complexities of this essential aspect of Java programming. Remember, understanding type conversion is a crucial part of mastering Java. Keep practicing and you'll get the hang of it in